Hello, everyone. I'd like to welcome you to today's webinar, Significant Changes to the 2021 IBC Part 2. My name is Marcy Weber, and I'll be the Education Team Moderator for today's presentation. Today's webinar is going to run 1.5 hours. The American Wood Council is a registered provider with the American Institute of Architects Continuing Education Systems. Please note that this webinar and associated slides should not be used as a substitute for competent engineering support and expertise. This course is copyrighted and not eligible for reproduction. Here's the team that's providing this course for you today. Our speaker is our very own Paul Armstrong. Our engineering moderator is Director of Educational Outreach, Lori Cook. And behind the scenes is our Education Administrator, Kim Paulson, and myself, Manager of Education and Accreditation, Marcy Weber. Now I'm going to hand you over to Paul to talk to you about the 2021 IBC.
Well, hello again. This is Paul Armstrong. This is part 2 of our journey through the 2021 International Building Code Significant Changes. I will again be your host, and we'll be going through certainly chapter 10 through the end of the code to identify at least the significant changes that we can talk about today. It is important to note that ICC does have a significant changes workbook for the International Building Code. It's very, very helpful. It's one of the things that I really like that ICC produced after I left. Wish I had this before. It's very, very handy. And then they also, if you really want to dig in to the International Building Code or other code, ICC code changes, they do have a history, if you will, of each particular proposal listed separately. And if you get the premium version of the ICC's codes electronic software, they have links that go directly to those code changes. And so it's very, very helpful for understanding the intent and the purpose of these code changes. Again, we'll be talking about what happened and resulted in the 2021 International Building Code. We'll be looking at, again, those changes that we can and discussing some of the impacts of those revisions. Here are our objectives, pretty obvious for this particular class, to identify the differences between the previous code, which was the 2018 edition, and the 2021 IBC. I'll go through and explain any new code concepts that there are as much as I can in the time that we're given. I'll try and identify certainly the impacts of those revisions on the various groups that are out there, in particular on the enforcement side, and note those issues as well. So we're going to start. We are in chapter 10. This is the first of those items that were identified as significant code changes in the 2021 edition. Very, very interesting to go through a lot of these. Like I said in part 1, while ICC sometimes identify these as modifications, I believe most even identified as modifications are really clarifications. And this really helps us with the application of the code to some of these areas, especially in chapter 10, where we need to provide egress paths from given areas within a building or structure. In this case, these are largely unoccupied mechanical rooms and penthouses. Penthouses are an allowable projection above the roof line itself, and so it does not work against the actual height of the building. The ICC code change in this particular case seems to identify the mechanical rooms as also being on the roof, but in reality, the way that the code is set up, this identifies the removal of the common path of travel determination for these unoccupied mechanical rooms wherever they're located within a building. Obviously, penthouses are on the roof by definition. We get that. And again, these are just very infrequently occupied, mostly by mechanical staff or facility staff and all that. service personnel who go through and effect repairs or maintenance. And so we don't really need to have this common path of travel. The exit access travel distance does apply still, like anything, but common path of travel allows us to basically have these particular rooms and spaces in areas that are probably not as desirable for most occupants of those buildings. Again, sticking with our exit access travel distance criteria, there is criteria in the code, a couple of tables that allow for a single exit from a story or an occupied roof now. The travel distance limitations are based only on exit access travel distance. We're already allowing a single exit. So we don't have to have the common path of travel determination applied in this particular case. It was very interesting to see the common path of travel applied in some of these very large, typically complete floor build-outs. They would have space left over for employee break rooms, things of that nature. And sometimes it was very limiting as to what kind of design you could have for those particular spaces. And you may actually have needed a second exit access doorway out of some of those spaces in the past. In this case, this allows us to have some of these unusually shaped spaces, maybe very long and narrow, like a shoebox kind of a thing, exist without having to have that determination or certainly that criteria to deal with. Again, we do spend a little bit of time with illumination. Very interesting exit sign identified in the picture here. That's the running person. That is something that is accepted internationally and is making its way here in the United States, much more so. Whenever we have exit access or exit stairways, both are stairways in this case, we want to make sure that people can actually see what they are using, because stairways are inherently, if you will, hazardous, just because of the tripping hazard. And so the level, the required level of illumination has been increased by 10-fold, from 1-foot candle to 10-foot candles. 1-foot candle is fairly dim. Actually, the slide or the picture in this slide kind of gives us an idea of what 1-foot candle may be like. I haven't measured this. It just looks very much like what I've seen for 1-foot candle types of locations. 10-foot candles can be fairly bright, and so we like that. Again, we don't want people to be surprised by that first riser in a stair, if you will, typically going down or going up, and then tripping and falling and then potentially hurting themselves. So this is a very good code change. I think it was something that was kind of a weakness in the previous codes in terms of providing the actual protection we're looking for the occupants that are served by these stairways. We've added a new condition for when we actually have to have certainly an elevator to different levels, and occupied roofs are now part of that. It's not just floor levels within the building. So whenever you have an occupied roof that is more than 4 stories, above the level of exit discharge and all that, then we have to have an elevator to that particular level, including the occupied roof. Obviously, there's accessibility concerns. There's a lot of issues built into this. This is in section 1009, which is for accessible means of egress. And we want to make sure that those particular facilities that are located in and on an occupied roof are available to people with disabilities. And this particular code change recognizes that. There's been a lot of work with occupied roofs in this particular code and the previous code, the 2018. And so we're actually seeing this pop up more and more, and probably will as we move on out into the future, certainly in the 2024 ICC codes. Sticking within the accessible means of egress criteria, we have interior areas of refuge that previously were only allowed to go to an elevator lobby or a stairway, lobby, again, or landing, that kind of a thing. We now can have these interior areas of refuge access exterior areas outside the building. It could actually go out to an exterior stair or just directly out to grade below with a landing and out to some sort of pathway away from the building. The idea again is that people can potentially reside there for a short while. Maybe there's some sort of a problem with getting down to grade or from that particular point. And so we allow for that interior of that refuge to also access the outside, not just stairways or elevators, which basically recognizes upper levels rather than the level perhaps at exit discharge and the like, or at grade. So it's a good code change. I think this will actually serve certainly people with disabilities very, very well. This is a very interesting code change to me, to lots of people actually. I really like the picture that's in this slide too. That was a good choice. The wheelchair space has long been 48 inches or 4 feet, if you will, in length, and is now increased by, obviously you can see there, another 4 inches. We're up to 52 inches. It's very, very interesting. You can see the second bullet. The intent is indeed to accommodate those larger types of powered mobility devices. That particular photo is a very good one, I think. For me personally, I had an uncle go through all the stages, unfortunately, of MS, and he went from a walker to a wheelchair to the powered type of device as well. And in fact, we did notice that it was larger than the space that we had previously required in most particular cases. And so it's something that is actually a little bit personal to me, and I think this is a great code change. We're still going to see a lot of accessibility code changes moving forward. In this particular case, we're still in the accessible means of egress, but we're getting, I think, a more realistic type of wheelchair space in those areas where we're setting aside these areas like interior areas of refuge we talked about previously in other areas. So again, a very good code change. This is a biggie because there are impacts with existing buildings. And I get that there's an international existing building code, but we have this criteria in the building code in chapter 11 and chapter 10 in this particular case. And we need to recognize that moving on and how we deal somehow with existing buildings that complied with the previous codes. So big code change, really is very small in terms of the actual change of the code itself, but the application of the code is going to be big. And I'm hoping certainly that the design community in particular has picked up on this and is already using this particular size of wheelchair space in their designs right now. Starting into chapter 11, we have a new addition. It's very, very interesting to see the adoption of standards. In this particular case, ICC is the secretariat for the A117.1 standard. They have been for a long time, very long time as a matter of fact. Had the opportunity when I was with the Model Code organizations to participate as an alternate, and it really has some very interesting discussions and work going on. You can see that the previous edition was the 2009 edition, and now the latest edition is 8 years later, 2017. So this tells us that it's not really linked up, certainly, with the adoption process or the publication process of the ICC codes, as many standards that are adopted by reference are also not linked up. So we get these periodically. It has been a little bit of a challenge to get this one through, but they've done that, and we now have that adopted. in the 2021 edition. So we need to have this available to us so that we can, either in our designs, in our enforcement, or the actual construction project on site, we need to know what those changes are, because they are in effect now when the local jurisdiction adopts the 2021 codes. This has been a real fun one. We now have criteria for electric vehicle charging stations into the code. We have at least 5% of the parking spaces, not less than one, of course, but at least 5% of all of those spaces, all the electrical vehicle charging spaces, excuse me, shall be accessible. All right. This has been something since I am based in California, and the bulk of my career has been here in California, has been very interesting for us to follow as well, because we already have this going on. This has been a huge question when we have the accessible parking spaces themselves required. At what point are we going to start requiring these EV charging stations that also serve accessible spaces? Well, here you go now. We have that. And so we have that criteria. The industry has been very proactive in working with ICC and working with others in developing certainly accessible features to their charging stations and all that. But we have this in the code, and this is a mandate that will be moving forward, obviously, with the adoption of the 2021 code. We do see a lot of electric vehicles popping up now, and frankly see a lot of people using these parking spaces to charge their vehicles, sometimes even when they're not using the facility where the EV charging station is located. But they get to use that, and we have that out there now, recognizing this trend for EV types of vehicles. Accessible bottle filling stations. We have a lot of these now. People are taking their hydro flasks with them all over the place. Whenever we have these stations provided, they shall be accessible. Mostly are triggered, if you will, or activated by either a press button feature in the back of the bottle filling station, or there's a sensor that notes that when the bottle is there, it needs to fill it. So they have them. Typically, it means they shall be within reach ranges, shall be available to somebody in a wheelchair, typically, that needs to fill up their bottle. However, there is an exception, excuse me, provided for those types of bottle filling facilities when they're over accessible drinking fountains. The drinking fountain is already accessible. Presumably, someone can drink from it instead of just filling up their water bottle or hydro flask when they get to that particular point. And so we recognize that as well. It's not a bad idea to have even these stations accessible, but that is not a mandate within the code based on this new exception. Moving on into Chapter 12. This is a fun one. We're familiar with Group E occupancies. Those are the educational occupancies. And a lot of our jurisdictions across the United States do enforce the code for schools, typically primary and secondary schools. But this mandates that we have, and basically in using the A117 accessibility standard, we have enhanced acoustics for certain classrooms. And those classrooms where these enhanced acoustics are required have a volume of 20,000 square feet or less. The larger ones presumably have that, and we're good with that, but we don't measure classrooms or any other building by volume typically. So we're going to have to know that. Certainly for a very standard and regular, rectangular shaped cube, it's very easy, but not all classrooms have that. And so we're going to have to go through and come up with a way of hopefully simply Otherwise, we have to go through a much more complicated method of determining the volume of these classrooms. So we have this here. In California, we don't actually use, just so you know, the A117 standard and all that. We have our own criteria, but we have this reference to the A117 standard as well. So it's the first time we're really getting to use that. It'll be very interesting to see how this plays out going out in the future. There are Group E occupancies that are not handled by states typically, or other individual types of authorities having jurisdiction, school districts, or some type of state educational agency. We do have private schools. So we've got to be able to understand that this is a volume type of a determination, and we've got to do this, again, like I said before, hopefully very simply, so that we can get these, get this particular determination done, and we can move on to what is the enhanced acoustical type of system that will be in place. Still in chapter 12, we're moving on into the dwelling, if you will, criteria. Efficiency dwellings. For years, we have had as a minimum floor area for efficiency dwellings, 220 square feet as the minimum floor area required. That has now been reduced to 190 square feet. In reality, what this does, this recognizes the movement towards smaller dwellings. This is not, if you will, typically tiny home kind of criteria. This is an efficiency type of a unit where all of the features are within one room. You can see that by bullet number 3 below. There's a new definition for efficiency dwelling unit. It does give certainly a little more flexibility for the reuse of buildings if, again, you're not working within the existing building code and all of that. It did remove the additional occupant load floor area requirement too. So it's 190 square feet, that's it. Doesn't matter how many occupants are living in that particular efficiency dwelling unit. This has been kind of a challenge out there, as well as certain people will rent out apartments to a very large number of folks. And then sometimes our housing authorities or code enforcement authorities have a challenge with trying to determine what is the minimum floor area for that particular dwelling unit based on the number of occupants that are within it. We don't have that anymore in the building code. Okay, we may have that in the housing code or a property maintenance code, you know, that kind of a thing, depending on what you've adopted in your jurisdiction or your state. But this just recognizes that these efficiency dwelling units need only be 190 square feet, period. Very, very interesting to see this, and it does kind of lend itself towards that tiny home sort of methodology, but in reality, it's just more of an affordability type of an issue for housing in particular. This is going to be a very interesting one to try and design to and try to enforce. We've had this in other areas, but this one in particular has some very interesting nuances to it. So public restrooms are now required to be visually screened from the outside entry or exit doors or whatever for privacy issues. So if you have a multi-facility type of a restroom, going to have to provide either screening or perhaps maybe a little different layout of the access into that particular restroom, so that when the door is open, people cannot look in and see, you know, what folks are doing, you know. So the challenging part is the second bullet. There's an analysis that's required if there are mirrors that could compromise privacy, that could be used to see people on the other side doing whatever it is they're doing, right? I don't know how or what method we are going to use to either design to that or certainly to enforce this particular provision. Obviously, there's a lot of public restrooms out there, and we're going to have to come up with something. Now, like with so many things in the code, there's exceptions. A lot of people say it's an exceptional code as a result. Well, great. But we have an exception, and an obvious one, for single occupant toilet rooms. Mostly because you get into that particular facility, that particular toilet room, turn around and you lock the door. So if you're in there taking care of business, right, people are not, at least generally, going to be able to open the door and then obviously see you there taking care of business. So we have an exception for that, but we're going to have some challenges with this. We're going to need, I hope ICC is going to work with folks about how this particular analysis using mirrors and all of that can be determined quickly, simply, easily. Frankly, I don't remember really, other than in terms of accessibility, looking at, if you will, or reviewing the layout of mirrors, other than the height, so that somebody perhaps in a wheelchair can actually see themselves in it. But in terms of the angles and things of that nature. So we have a little bit of a challenge with this. It's a very simple code change, I think, but it's got some big impacts on both the design, certainly, and the enforcement side, all told. So I hope there's not too much trouble out there with this particular one, and that ICC comes up with a good policy that can be used in terms of the methodology. Chapter 14. There has been a ton of work, and there continues to be a lot of work in the code development cycles on vapor retarders and water-resistant barriers. There's a lot of concern with that. The control of moisture is huge. Okay, this particular code change reorganizes, and I think there's a C word in the third line, clarifies the application of these provisions much more simply than I've seen in the past. Okay, I have not enforced this particular criteria myself yet, but I would, of course, I am with American Wood Council. I won't be enforcing this, but in any case, we'll be talking with friends who are going to be enforcing this to see exactly how this works out going on into the future. But I think that they've done an excellent job in making this criteria a much simpler set of requirements for the application of various types of vapor retarders, depending on whatever climate zone you're in. And we have other criteria here too. The funny thing with a lot of this is that these particular code changes frequently go in front of the IBC structural code development committee, and it's not exactly a structural concern, but they get to hear all of the code changes and make a recommendation moving on to the ICC membership for these particular elements. So it's a very interesting thing. Note that obviously this is related to energy conservation, it's related to the control of moisture. We're going to be seeing moving on into the future, I think for several cycles of codes, a lot more work, or if you will, significant changes that will be coming up. The application of metal composite materials as a cladding itself. This has been a big issue internationally even. We've had some very massive, big fires, massive fires that have been very difficult to control, because the fires then they gain access to the inside of these particular assemblies, and there's no sprinkler head in there, and so they can race right up the top of the to the top of the building relatively easily and quickly. The criteria has been simplified by limiting the height of the prescriptive criteria up to 40 feet only. Above that, okay, if you have the application of this particular material, this cladding material above that, then we need to see that there's been full-scale testing, as you can see, to NFPA 285 provided. The alternate provisions that we've had previously were not felt to be that desirable, and so they were eliminated altogether. And so we have either the prescriptive criteria that we have in the code itself, or just the application of them up to 40 feet, and then 40 feet and above, we need to make sure that that particular product has an evaluation report or has some sort of listing and is highly tested to NFPA 285 moving forward to provide the fire protection that we're looking for in this particular application. Again, I think this is another good code change, although there's a funny thing about this. At least to me, it's funny. I've been in this business over 30 years, well, 35 years really. And we've dealt with parapets from that time till now. The parapet criteria has been split into two, which is good. Non-rated and fire resistance rated parapets. I think that's a great idea. The second bullet's another one. The top must be coped or covered with some sort of weatherproof material. Awesome. Okay, and certainly as the parapet projects up to whatever height it is, 30 inches presumably, that sort of a thing, the fire resistance rating has to continue. Now, to me, these parapet walls are maybe 8-10 inches in width, something like that. The third bullet is a funny one to me. This is something that's going to impact certainly the people doing the construction, but our inspectors as well. So we need to make sure that the top surface, that coping or whatever that surface is that's protecting the top of that parapet wall, has to have positive water drainage because it's exposed to the outside and presumably it's going to rain at some point, right? For that 8 to 10 or whatever the thickness of the wall is. So we're going to have to see a slant, if you will, one way or the other. It doesn't say where the water has to go or where it has to drain, just has to drain off of that parapet wall. So it's kind of a funny one. It's one that is a pretty small detail, but our inspectors in particular are going to have to know this when they're looking at these particular projects. Maybe they're large multifamily projects or hotels or something like that where you do have interior parapets in particular, but this also applies potentially to exterior parapets when they're required to. This is another funny one. There's been a few of those this particular cycle, by the way. Whenever someone is proposing to use an aggregate surface roof, ballasted roof using aggregate, that kind of a thing, then we have to make sure in those areas that are subject, well, all areas really, but based on wind speed and the exposure, okay, we're going to have parapets provided to help, if you will, corral or keep that aggregate as much as possible on that roof. If you look at the table has, it's very interesting. I think the maximum height of the parapet is like 56 inches or somewhere around there. But the minimum height, without even considering, if you will, wind speed, is a 2-inch parapet. That's going to be a funny one, especially considering some of the criteria we had in the previous slide and all of that. Okay, but someone using this aggregate ballasted type of system or aggregate surfaced roof, okay, they're going to have to make sure that they have the parapets provided that will help to contain this aggregate based on wind speed. And we all get, when you're in hurricane zones or whatever, you've got a very large wind speed and all that, and certainly your exposure is out there as well, that this aggregate has a tendency to launch and become like a shotgun blast to adjacent properties and people and things that are in its way. It's just a funny thing that no matter what, even if you're in a very moderate or low wind speed area, you still have to have at least a 2-inch parapet based on the exposure as well. So take a look at this. This may have some challenges for existing buildings potentially, I think. We don't have a lot of criteria in the International Existing Building Code related to re-roofs. But when they are re-roofing some of these older buildings that use this particular roofing system, we may have some very difficult discussions, unfortunately, along those lines. So watch out for this one, especially our inspectors in particular. A lot of our re-roof permits are something that are issued over the counter, and we don't get a lot of information on the building itself typically. So it's all pushed out to, unfortunately, pushed out to the field where, again, you have some very difficult discussions at time. And I hope certainly that our roofing contractors are getting this education. The National Roofing Contractors Association and others very active in the code development process. So I would assume that they're training as many of their people as they can. So again, watch out for this one. Okay, we've gone through, well, including part 1, which was previously, we've gone through the first 15 chapters. We're moving into some of our structural criteria. We don't have a lot of slides in this. This is not intended to be any sort of in-depth structural analysis of significant changes. We identify those areas that are going to be important for everybody to know. If you want to have some of that little more in-depth type of analysis, ICC and others, ASCE has some, but ICC in particular, SK Goshen Associates, which is the subsidiary of ICC, provides that, and be really good to pop in on those particular seminars too. Now, with that being said, this is something right here that applies to our counter staff, applies to the people that evaluate what is a complete construction document, plan reviewers, certainly our engineers in particular. When we have, a wind design analysis, we are going to not only need the wind speed, but we're going to have the exterior components and cladding little figures identified as well, the wind pressure zones that are on those figures identified, okay, in the construction documents. So it's either going to be, typically like on sheet S1 of the plan set, or it's going to be where I would expect it more often than not would be in the structural calculations where we have our wind analysis. So we're going to have to see these particular zones. We're going to have to see what's actually applied to those zones based on the design that's being provided for permitting. So engineers, architects, if you're running these yourselves, our permit staff, our plan reviewers and all of that, you're going to have to look for this too during your particular activity, your work. So be aware, we're looking for these figures and we're looking for those zones identified and certainly the loading that is imposed. Assembly space risk categories. This has been kind of a fun one because I didn't realize in going through and applying the code previously that we had a problem with this, but we did. And so they've identified this, and it's a really good code change. The previous code said that if you had a building whose primary purpose was just this assembly use of 300 or more occupants, then you would apply, the increased risk category, right? But we have buildings whose primary purpose is not just assembly, it's much bigger than that, if you will. Could be a hotel, could be other types of facilities and uses and the like, where we have multiple assembly rooms with an occupant load of 300 or more. Okay, with and then there's the whole occupant load, the cumulative occupant load of that of 2,500. Then we have those fit into the increased risk category too. Okay, a lot of this is being coordinated with ASCE 7, the ASCE and the FEMA Seismic Code Support Committee and others, NCSEA, which is the National Council of Structural Engineering Associations, and a number of other groups are tracking this very, very closely. And they're trying to make certainly what's provided in those structural standards consistent with what's in the IBC, and the IBC consistent with those structural standards. The challenge that we have, like we mentioned before with the adoption of the 2017 A117 standard, is that sometimes we don't get the latest and greatest, if you will, edition of those particular standards imposed in a given code just based on the publication schedules of those codes. Okay, but we need to understand that we have this here. Engineers and architects, engineers in particular, certainly in the state I happen to be in, California, are held to a higher level than just the minimum code. If there's something that is out there in a particular standard that is certainly or needs to be included within your design, then you're going to have to use that. And you're going to have to use potentially the increased risk category, which we can, from an enforcement standpoint, allow, because that goes above and beyond the minimum at that time of the code that's, you know, in effect at that time, waiting for a future code to come into play. We can do that because it goes above and beyond, but sometimes that's difficult for people to understand. Just know that we have this now, and that we have people that are groups in particular that are very interested in keeping the codes and the standards as up to date as possible, which helps us in the long run. I included this one. I just find this one kind of funny. I don't know that I have ever looked, reviewed, designed, what have you, a fixed ladder that serves typically some sort of industrial type of structure. Maybe it's some sort of industrial work platform, who knows? Okay, but we now have loading criteria for those fixed ladders, and as it says, including ship's ladders. And those are typically, they're just a little different design. They are ladders, if you will. They're just angled a bit, and they have a place for each foot. Okay, but we have this design that's now called out in the code. So when it's called out in the code, guess what? We have to review for that now. Okay, and we have to design for that. Now, a lot of these are prefabricated types, from what I understand, prefabricated types of ladders and things of that nature. Unfortunately, they've been used over and over again, and the engineers that are involved with those industrial factory storage, if you will, types of uses are very familiar with this criteria, but it's just something that we now have to look for on the enforcement side in plan review. Okay, presumably out in the out in the field where the project is actually being constructed, our inspectors are going to have to know that that's done too. It just can't be something that's brought in. It could be then an RFI where you send them back, if you will, to have the actual ladder configurations perhaps reviewed by your plan review staff. But we have that now in the code, and we have to look for that. So there's more and more being added from a structural standpoint too, that we have to make sure is included within the construction docs and within the analysis that is provided. Kind of a challenge at times. It just seems like there, sometimes there are things that are being added that we haven't had trouble with in the past, but we have to include them now. And so that's what I think, in my feeling, and it's my opinion only, has happened in this particular case. Okay, chapter 17, our structural observation and our special inspection type of criteria. This basically causes us to view chapter 17 as more of a QA, QC type of set of criteria. Structural observation was developed, probably 30 years ago. It's been quite a while. I remember when the structural engineers were starting to bring this into the codes, legacy codes, and all that. But we now have to make sure that the structural observation stages or inspections are called out in the approved construction documents. Okay, we want to make sure that that's listed there so it's obvious as it can be to anybody. Now, one of the unfortunate aspects about construction is that usually when you get into the job, usually those general notes and those observation points and all of that and special inspection requirements sometimes get folded in the back, and they're working directly on the framing plan for whatever type of structure it is. But we need to make sure that this is happening. The structural observation process also has to be something that is known and continues to be a regular process for our engineers who are doing the design, so that their people can come out and make sure that what's been in the approved construction documents actually occurs in the field. Obviously, it's been modified again. There people are looking at how to make things simpler and easier for us to use, and I like that a lot. You can see the application has changed, especially in seismic design category E. You have greater than 2-story structures now that actually have structural observation criteria within. So we need to see this on the plans. Okay, it can't just be something that's in the agreement or in some other document. It has to come into the building department for review. Special inspection criteria. You're going to see not just in these particular slides we have here today, but in other cases that there is a lot more special inspection criteria. They're actually causing these special inspectors, or people used to call them deputy inspectors, to go out in the field much more so than they have in the past. Typically, they're looking at connections. And you can see, certainly in this particular case, that's what we've got. Although item 2 says the completion of reinforcement across joints. Well, that joint interface is really like a connection. Okay, and we want to make sure that those are done correctly and that they're done in a quality, if you will, workmanship-like manner, right? Because if there's going to be a failure with precast systems, it's not going to be typically in the precast element itself. It would be in the connections. And so we want to make sure that those are done properly. We get those. We've got a lot of criteria in Chapter 17 that you're going to be seeing. Some of that today, but if you're not familiar with that, certainly you need to dive into this particular area, because there is the application of this criteria is becoming much more rampant than we've had in the past, and has really created new industries, or new industry group in particular, for conducting these special inspections. We have also now an adoption of ACI 550.5. For some reason, that's hard to say, which gives us installation tolerances, which we don't have tolerances in just about anything else. Okay, but we have that here, and the special inspectors are going to make sure that certainly in these precast elements, okay, we're getting those precast elements installed within the ranges we're looking for. And so we've got that now. ACI has their own standards development committee that has worked on this along with ACI 318 and others. We'll talk about that in a minute. But we have that being handled by industry. So hopefully, certainly the people out in the field that are doing concrete construction, in particular precast concrete construction, know about this and are complying with this already. So it's very interesting to see these standards added. Presumably, we'll be looking at other types of tolerance based standards in the future. And this is one of the first ones that we've had. Moving on into masonry, in risk category 4 structures, they basically have eliminated the application of empirical design or empirically designed masonry. As such, we don't need to provide special inspection for it because it's not allowed. So effectively, they've taken that out. It's a coordination code change with what occurs in the masonry chapter in the IBC. Mass timber. We talked about this in the first part quite a bit, actually. It has really been, like I said before, a code change that is one of the biggest code changes I've seen in the construction material area ever, honestly. While it uses timber in such a way that it's brand new to a lot of us. And certainly the inclusion of type 4A, type 4B, and type 4C construction that allows for much taller buildings than we're used to is very, very interesting. In fact, there's been some testing recently at the UC San Diego shake table, where they're testing a 10-story full, if you will, mass timber building to different earthquake loads that we've seen, or based on earthquakes that we've seen, and to see how they go forward. So we're going to see a lot more of complete mass timber buildings going out. As I said earlier, with special inspections in particular, we are concerned about the connections. These are like precast concrete. These are prefabricated panels, typically, or prefabricated elements. And so they have their own QA, QC in the factory based on their approval as an approved fabricator. So we're going to see the erection of the structure, which leads into all of the laundry list of connections that need to have a special inspection as they're being erected, as this building is being erected. Now, the funny thing about this is that you can use mass timber and other types of construction. I would still take a look if it's another type of construction, maybe it's type 3 that happens to use CLT floors, things along those lines. I would still take a look at this package to see what would apply and to make sure that those connections are, in fact, getting the inspection, the QA, QC, that we all want for all of the built environment. But know that we've got this here. The mass timber package was complete, and they're still working on bits and pieces, typically, like I said, based on research that's being done, conducted right now, even as we speak. So it'll be very interesting to see how all this moves forward. But I would expect for a special inspection criteria for these connectors to stay in place. Steel storage racks. This has been a fun one. We get a lot of steel storage rack configurations out there in our big box stores and our large distribution warehouses, among others. Okay. The industry itself, the manufacturers of these systems, has been very concerned about certainly the application and the installation of these rack systems. And so they actually put forward this particular code change to make sure that what is being installed, rather, out in the field is what is on their approved construction documents, because they have engineers that put these together, and they're based on certainly the information they have for their particular products. They want to make sure that all that gets put into place. So as we talked about earlier, special inspection is concerned about connections. We get that. Items number 3 and 4 in particular are based on that. The completion of the storage rack system, it's all put together well. The anchorage, obviously, we want to make sure that it's anchored down to the footing or the slab sufficiently. Materials in compliance, fabricated elements and materials in compliance with approved documents is a very interesting discussion, because apparently in some cases, people are mixing and matching some different manufacturers' criteria or elements in a given steel storage rack installation. And that's not a good thing at all. That violates certainly their warranties and all of that. And so we have a real problem out in the field. This really falls mostly on certainly our inspectors to make sure that the special inspection staff that's out there are doing their job, because this is brand spanking new. So make sure that they are qualified to do these kinds of inspections, and you're getting the reports that you need. In residential types of setting, very large residential types of settings, when you have fire areas, maybe separated by firewalls, things along those lines, where there's an occupant load of 250 or greater, okay, we get it, the increased risk category. But in this particular case, we're in the special inspection criteria. We impose in the code special inspection of all of these penetration types of elements. Okay, so it's not just conduit going through walls, it's the joints in between elements, and it's even the exterior joints between cladding and a fire resistant floor that gets this criteria. We need to make sure that our special inspection staff are inspecting those and providing us with the reports that are necessary. Okay, we have a lot of people that are living in these settings, okay, 24/7 presumably, right? And so we want to make sure that they're provided with the protection that we expect for these Group R occupancies in these typically large apartment hotels, perhaps, other types of settings too. Okay. This one has a big impact on our inspection staff. We have now a label that is required for garage doors and for rolling, typically vertical rolling doors. That label has to be a pretty good sized label because it includes a lot of information. And then someone, this isn't 1709, this is not special inspection, someone is going to make sure that that label exists and that that door is appropriate for that particular installation. So you get the door manufacturer, the make and model, we get that. Typically you see that anyway because they identify their various models and their own doors. But we get also the positive and negative wind design pressures that this door has been tested to and can comply with. We get the installation instruction drawing reference number, something I don't think that I've ever seen on a label before. And we get the applicable test standard included. So we have to have all this information. Our inspection staff are going to have to verify this so that that door can be approved. Now, we don't have a lot of, at least I haven't seen a lot of retrofit types of or replacement door permits in these types of settings. But if they do happen to come in, certainly we would make sure that this label exists. But typically in new projects, this is where we're going to see this more and more. Impact protection, in part one, we talked about the definition. We already make reference to it in chapter 2. We have that criteria called out here. ASTM E1886 and E1996 are the standards for the window protection that are imposed, in those areas where you have wind-borne debris. It's hard to say that for some reason, but we have that imposed on this here. Required exit. This is a funny one to me. Living in California, we don't get this that much, at least from a day-to-day experience in the winter. But we have all outward swinging exit doors shall have frost protection necessary to ensure the unobstructed opening of those doors in the event of a winter storm, presumably, right? Very, very interesting considering that this year, 2022 into 2023, here in California and other parts of the country, we had a very big winter and we had upwards of 40 feet of snow. Very difficult to keep those swinging doors clear and all that, but it's supposed to be there. We're supposed to have that kind of frost protection provided. New edition of ACI 318. You can see the previous edition was the 2014. We now have adopted the 2019 and the 2021 code. It's only a 5-year difference between the adoption of those particular, in this case, concrete standard. But we have that new edition. No, certainly for an engineer or perhaps an architect who can do that, and our plan review staff, that we now use the 2019 edition. Here is more within our concrete tolerances. Okay, we have, again, in keeping with what we had with ACI 550.5, we have structural concrete tolerances also in the IBC. Again, the important thing is look at the exceptions. Shotcrete, we get that gunite kind of a thing. The tolerances aren't built into that. It really wasn't intended for that, and there's a different standard for that. And then for basically single-family dwellings and duplexes, we don't have these standards imposed, but for everything else, we do. So know that that is a part of certainly the code that we're now starting to enforce. Keeping up with the steel storage rack criteria for rack structures that are 8 feet in height or greater, of course. And there's plenty of those. You go into big box stores or distribution warehouses and all of that. We understand those. They are big structures. Also, they happen to be constructed in or proposed in a seismic design category D, E, or F. Again, being here in California, there's other places I get it that have this seismic design category. A completion certificate is provided to the owner or the owner's rep, indicating that the system has been installed per the approved construction documents. This is in the code itself. Okay, we need to make sure that certainly the installation folks out there understand that this is here, and this is basically pointing to our inspection staff to make sure that they're getting these certifications, hard to say again, with these installs once they're done. Okay, again, they're fairly tall, doesn't give a floor area per se, but they're in high seismic design category areas, and so we want to make sure that this has been done to those approved construction documents. Chapter 23, we have a number of code changes here. I'm with the American Wood Council, and obviously we put an emphasis on this, rightly so. We have additional consideration for the effects of cross-grain changes, if you will, that can occur when wood dries, okay, after insulation. Typically, we don't assume that wood is getting, more moist, but that it's drying out because it's within a wall assembly or it's exposed to the interior and the environment is drying it out, pulling the moisture out and exhausting it to the outside. We want to make sure that any sort of dimensional changes that occur are accounted for in the design. Connection fire resistance, this is our mass timber criteria. Again, look at this, it's for our connections. There's protection applied to the mass timber types of construction A, B, and C, but we want to make sure that the protection for the connections is also provided. So there's either, testing of the type of connection detail that's provided or some sort of engineering analysis that goes along with it that makes sure that our connections of these mass timber elements are going to withstand certainly the fire or the effects of the fire in that particular design. So we have that built into this criteria now. It's in the 2021 IBC. We've got a lot more fasteners going on here. Typically, we're doing research. In this case, there's been wind criteria that has caused us to look at the fasteners and to provide a little more detail for our nails in particular. And so we have that in our fastener table or the fastener schedule, if you will. And so we need to make sure that that is in our projects, or at least imposed on our projects. This criteria is consistent with typically the national design specification that the American Wood Council publishes and promotes. Here we have the 2021 edition of the special design provisions for wind and seismic. That's been adopted. You can see the previous edition was the 2015 edition. So you can see there's a 6-year gap here. Every standard developing organization has a different process. Sometimes those processes flex based on the ideas that are being discussed. They may need more time to do that. But in this particular case, we're getting the latest and greatest from our seismic design criteria and wind design criteria in this particular standard. Rafter tie connections, getting, again, connections. You can see that there's a theme with a lot of these code changes. We want to make sure the connections are done in a code complying and quality manner, because that's where the weakness point is. And so we're talking about certainly our heel joint connections in this particular case. We want to make sure that they're provided in the manner that we need them. Take a look at this if you're doing wood design. Chapter 23 has a number of changes throughout. We've only picked up on a few, but go through and get into that particular criteria and understand what's being imposed. We've moved on to chapter 25. Again, like our vapor retarders, we have water resistive barriers, WRBs. In this case, these are for stucco. I really like this code change. They've simplified it. They've divided it into really only 2 subsections. when you have dry climate, and then when you have a moist or marine climate. Okay, and then we can impose the criteria for these water-resistant barriers. Again, this is for moisture control and has an impact certainly on energy conservation code requirements too. Chapter 31, we're getting close to the end. This is a clarification of temporary structures that are used in special event structures. You can see the application at the bottom. They're ground-supported platforms, other types of, it's not scaffolding exactly, but other types of support equipment for lighting, for speakers, things along those lines that are related to the entertainment events that occur out there. And so we have more information provided for us for those particular structures. This is a fun one, the use of shipping containers or intermodal shipping containers. This has popped up. Actually, a friend of mine has had a huge impact here. He's the building official for the city of Long Beach, Trong Nguyen. City of Long Beach has the Port of Long Beach also, and right next to it is the Port of LA. And so they have a huge concern with the reuse of these shipping containers. So if you happen to have these projects come forward where they're trying to reuse these shipping containers to create a brewery or some cases housing, but mostly I've seen them in more office or retail types of settings. We have the criteria now here. This has gone through a significant amount of review by structural engineers, by people in the fire industry, by all sorts of folks, and they've come up with this criteria that's really very helpful when people want to have this unique feel type of development going on in their jurisdiction. And we have a few around where I live that we go to periodically, and it really is kind of a cool feeling, outdoor music and things of that nature, and it gives some of our smaller businesses also a chance to try and really, you know, grow their ideas in whatever their business is in a much more small and more affordable type of setting. Chapter 35. Again, we've already talked about at least, well, one of these standards, the SPIDWIS. We have the permanent wood foundation design specification updated to the 2021 edition. We also have our cross-laminated timber specification in the code itself in the 2019 standards. So we're getting these more up-to-date standards out there for our engineers and our architects and certainly our plan review staff to use in the analysis of these particular projects. Industry goes to a lot of trouble to develop these and to provide the latest and greatest information for the design and enforcement industries. Here we've moved on into the appendix. I think this is our last slide, actually. This is, however, a very interesting slide. Very simple, just one sentence. But we have a new appendix chapter now that has been built into the 2021 code. It refers to, it adopts, if you will, the ICC performance code for buildings and facilities. Other parts of the world, the international environment, can use, they have their own performance code. Okay, we are starting to get this, our performance code built into, if you will, a more regular part of our design and construction analysis. Very, very interesting to look at this. Know that this is the future. We are seeing more performance types of studies that are going on out there that are being put in front of us, typically by an alternate means, that kind of a thing. But we have this code now that we can use if we desire, moving on out into the future. We could have done that before, and some of us have, but we have that actually in an appendix that can be adopted by the local jurisdiction, right? So know that that's there. Know that, again, this is the future. If you're interested in this, or certainly you're starting out in the business, you better at least understand what this says, okay, and where this is going. So with that, what I'd like to do is open it up for any questions. Feel free, even after we're done, I would be more than happy to respond to emails, to respond to texts, you know, whatever, on issues related to the application of enforcement of the 2021 International Building Code. Thank you very much.
Thank you, Paul. So we had a handful of questions come in. One of them I will answer because it's related to part 1 that Paul presented for us last month. And some folks were asking if the slides for part 1 are available. Is the recording from part 1 available? The answer is yes. If you go in the handouts tab of the GoToWebinar dashboard, you'll find a resource document. In there will be a link to part 1 on our website. So go ahead, and if you want to rewatch it or watch it for the first time, that is available on there. Paul, we had a couple of questions come in on the electric vehicle charging requirements. Do those requirements apply when you're adding chargers to an existing parking lot? Would it be possible to use an existing van space for an electric vehicle charger space?
That is a great question. And as we've said before, the code is really set up for new construction. However, we use it for existing construction all the time. And to me, depending on where you're located, I would talk with the local building official. I would allow it in an existing accessible van space. However, like here in California, we have some different regulations. So you have to find out if there's anything that has been changed or is enforced differently in your local jurisdiction. There is a big concern with not having enough EV charging capacity. So most of the jurisdictions I know are encouraging that. So I hope that helps.
All right. We had a question on Chapter 1604.5. I believe it's risk category changes. Yeah. Would that apply to shopping malls? I know that's a big thing where I live right now. There's a lot of old shopping malls that are being repurposed and converted and having some of their uses changed.
That is interesting. I would have to take a look. It could. I mean, each individual space has to exceed an occupant load of 300 or 300 or more. And then the combined, obviously, occupant load of the space is 2,500 or more. Now, the challenge that you have is that in a lot of the malls, each space, with the exception of the mall area itself, are not assembly uses. This applies to when you have assembly uses. Now, the mall is, I get it. The malls have been looked at a little bit differently. You know, if they're going to repurpose malls into some of these larger assembly kinds of uses, maybe it's, I don't know, a large restaurant or a brewery or whatever, right? You could start to run into that. I'd be a little bit leery of that, but for the most part, I know a lot of jurisdictions, as you said, Lori, are very concerned with the repurposing of these malls, and rightly so. And so it remains to be seen. I hate to say it again, but talk to your local building department when you've got an idea or plans, just rough plans for the reuse of some of these covered mall buildings.
Excellent. All right. Question on intermodal shipping containers. Does that apply only to repurposed containers and not newly constructed structures meant to mimic a shipping container?
Okay, this applies to the actual use of intermodal shipping containers. I said repurposed. I suppose they could be new. However, there is a project that is near to where I am right here that actually used a kind of a look that is similar to shipping containers, but they didn't use the shipping container itself. They had that kind of a very large corrugated wall, effectively, or there's actually a couple of them. I would not impose the shipping container criteria on that necessarily. The criteria was really set up for the use of shipping containers, whether new or repurposed, because they have some unique characteristics. Obviously, they're very limited in size, And to get any sort of large use within them, you have to attach them, you have to open them up, you've got to do a number of things structurally to them, and the standard actually, or the code actually addresses that. But if they're just trying to use as a finished material something that looks like a shipping container, I would not impose the criteria on that necessarily.
All right. Thank you so much, Paul. I think we'll give it back to Marcy now for a few closing remarks. Thank you again to all of you for sticking with us through.
If you are a code or fire official, go to our website to check out our free program for individuals employed by governmental jurisdictions. And that concludes the American Institute of Architects Continuing Education Systems course. We appreciate your time. Have a great weekend and take care.
Thank you, everybody. Take care.